All right, let's look at some more where clause techniques. And we're going to talk about wildcards. So what if I want to get some employees out? We'll just select last names from the employees table. Or my enter key did it again. From the employees table. And we'll just run that real quickly. So SQL statements are often built this way. I'm going to do some more things in the where clause here, and later on you're going to learn a bunch of other clauses. But we start with a simple query. Let's test it, make sure it works. All right, there's all the last names. And now I want to do something to modify that. And if you build your queries step by step and test them in between, it makes them a whole lot easier to troubleshoot than if I tried to do a really long, complicated query that maybe did 4 or 5 special things. And if it failed, you didn't know quite which one failed. But if I add them one step at a time, I can do that. So we're going to do a where clause. And we're going to talk about a couple things. We're going to talk about some wildcard characters. And the 2 wildcard characters, I'm going to type them up here, are the %. And the % stands for any sequence of 0 or more characters. It's a substitute saying we don't care except any sequence of 0 or more characters. And then we also have the underscore, which is for a single character. So let's see how to use those. Let's start with last name and we use that with these with a keyword called like, where the last name is like. Now we have to tell it a pattern. I don't care. We want it to be anybody with a D followed by any other characters. I'm trying to find that employee. I can't remember his name exactly, but I remember it started with a D. So I can do D and then the %. And this will show me any name that starts with D and has any sequence of 0 or more characters. If we had somebody whose last name was D, it would also find just that. So anything that starts with a D followed by anything else. Don't highlight it. And that shows me Davis and Dehan. Oh yeah, Dehan, that's the guy I was thinking of. Right? So the % was a wild card. I didn't have to put Davies or Dehan. I just said show me a D followed by anything else. What about, I want to see, now I'm just going to highlight the first part of this so it'll run select from employees again. I can see them all. Let me pick out all the people who have O for the second letter of their name. Okay, I can see Kochar there. This Morgas, he's got a O as a second letter. This is a really slow way to do it though, right? So I can do this. Any letter followed by, so the underscore stands for any single letter, followed by a lowercase o, followed by any other letters. And see, I had missed one. I missed Lawrence. He was in there somewhere. So that showed me everybody who has an O for the second letter of their name. So these wildcard characters can be combined to make some basic patterns that we can look for in words. Let me find anybody who has, I'm going to put a % here, any characters followed by a CH. So if they have 0 or more characters followed by a CH followed by 0 or more characters, this basically show me all the names with people that have CH in their name. And Kochar is the only one. Case. Let me see if I can get another clever one out of there. How about OS. Show me all the people who have an OS in their name. So they can start with anything, they can end with anything, but somewhere they got to have an OS. And we see Matos and Morgos. So those are wildcard characters. All right, and the last thing we're going to talk about today is null values. Now we've talked about null a little bit, and we've stressed that a null is not a zero, it's not a space. A null is a value that we don't know. It's not set. It's never been set. It's an entry in our database at the intersection of some column and some row that does not have a value. And we've talked about the fact that some columns require you to always have values, and some columns allow null values to be there. So let's do an example. We'll just do a quick select statement. Get the last name and get the manager ID to start with. We'll find out everybody's manager's ID. Then that's from the employees table. And I capitalized employees, and I've been consistent, so I'm going to stay consistent. And I need to spell it correctly. So here's a list of last names and then their manager ID. Notice that. We have Stephen King up here. I remember his name. I think these are all authors in this database. Stephen King does not have a manager. I believe that's because he's the CEO, and the guy at the top doesn't really have anybody that manages him. So his value is null. So what if we want to do this? Where manager ID equals null. Will that work? It didn't work. Now we talked about this previously. If we do any kind of expression with a null, any kind of math, the answer is always null. So if I take a number and I multiply it by a null value, I get null for the answer. The same thing happens with these. We know there's somebody in there because we just saw that King had null for their manager ID. Okay. So we can't use regular comparison operators when we check for null values. So instead, we have to use some keywords, and we're going to use is null. So select, so we use the keyword is followed by null to find out who has null values, and we get Stephen King. And we can also do is not null. And this shows me everybody but him. In this case, he's the only one in this particular business scenario. He's the only one that does not have a manager. So anytime you're checking for nulls, you can't use equal signs, greater thans, less thans, or any of the other comparators. We have to use is not null or is null, depending on what we're looking for. Let's do one more example with this. Let's look at commissions. Because I think we did some formulas last week, some expressions. I'm just going to run the top two lines. So we got a lot of people have nulls for their commission, but a few people in the, if you remember from last week, in the sales department, those people had commission rate set. So we can say where commission percent is null, and we can execute that, and it shows me the people that just have nulls for their commission percent, or show me the people who do not have null values, and it shows me all my salespeople. All right, that's the end of the videos for this week. There is an exercise in the lesson plan folder called lab work. Let me demonstrate what's in there. But here it is. So we have our vocabulary. You'll have 11 vocabulary words that I've talked about that you can go through. The notes, all these exercises I did are all in another document called week2examples.sql. So you can open that and go through these if you need to review them. And then these general questions are things you're just going to look up and answer. What columns can be null in the jobs table? You go look at the table and you look at its definitions and go through, can this be null or is it not null? When you get down to these, numbers 8 through 19, write and test SQL statements that answer the following questions. So I don't want to know, I could care less about the employees and their email addresses. I want you to give me the SQL command that will show me the employee names and their email addresses. Okay. Then when you give that to me as part of your homework in a SQL file, I can just highlight it and hit execute, and I can ensure that it works. So list employees by first and last name in a column called full name, followed by their phone number. There again. Which employees were hired before 19? There's a little typo. Before 1999. I might have actually done that one. Again, I don't want you to list the employees that were hired before 1999. I want to know the statement, the SQL statement that will give me that answer. And then down here, the last three problems, there's a little table definition. And then it asks you to write some statements based on what you know about that table and its columns. So it's not a table that actually exists in our database. You'll need to write the statement just based on the definition you see here. Technically, if you're not sure of it, you could always create a table, and you do not really know how to do that yet. But if you want to try and figure it out, you could create a table with those in there and then try to run it. But you shouldn't need to. You should be able to look at this and figure it out based on the table definition. All right, so that's the 22 problems plus the 11 vocabulary words for this week.